So we're going to talk about the different kinds of devices, just some basic devices that use magnetism. First one is speakers. And so speakers convert electrical energy into sound energy. So you plug it in the wall and sound comes out. I'm not going to go into a lot of specifics for this in case a group in your class wants to do this as a project. I'm not going to give them all their information. But the basic idea is it uses an electromagnet and a permanent magnet to then cause the speaker to pump in and out to create the sound waves. So a speaker goes electrical to sound. So plug it in, create sound. A motor converts electrical to mechanical. And again, it consists of a permanent magnet and an electromagnet. And so the basics of this one, again, not going into a whole lot of detail, you have your permanent magnet that will always have a permanent north and a permanent south, and then you have this arm, which is the electromagnet, which goes to some sort of power source, and this will change. It'll alternate between north and south. And so it will attract, repel, attract, repel, attract, repel, causing this arm to spin. So this is like blenders, food processors, anything that you plug in that turns is an electrical motor. This is not like in your car, the motor in your car. That is a different type of motor. And then we have generators, and generators work by electromagnetic induction. So this is a really important vocab term. Electromagnetic induction is producing current by moving a magnet through a coil of wire. Or you can move a coil of wire near a magnet. So this is like in the Bill Nye video that we watched about AC/DC current, and you watched Bill Nye spin the coil of wire, and you saw that it produced that alternating left and right current. So this is what's going on, is that the electrons in the wire are interacting with the magnetic field of the magnet. So this produces alternating current because, as you can see here, it goes positive, 0, negative, 0. Now the important thing to note is notice that you only get current when the magnet is moving. There has to be motion of the magnet or motion of the coil to produce current. If you just have this magnet sitting, and you can notice whenever it's sitting still, the current is 0. Generators, because you have to move something to create electricity, converts mechanical into electrical. So moving into electricity, mechanical to electrical. This one is opposite a motor. And then there's transformers, and not the robots in disguise. It's these boxes that are on your utility poles in your neighborhood. So transformers are created to increase or decrease voltage by electromagnetic induction. So we have a certain amount of current or a certain amount of voltage that comes in, and because of that electromagnet, it creates a certain field which then changes the voltage in the second coil. So this is a double coil system. So electricity is carried over long distances at a high voltage. So I should say voltage. Electricity carried over long distances at a high voltage. You step it up, so there are step-up transformers at the power plant that produces high voltage, and then you have step-down transformers that go into neighborhoods and then into your house. So step up at the plant, step down at your house. And this is why. Power plants produce voltage at roughly 6,000 volts. You don't want that going in your house. But that's not high enough to get it from the power plant that's way miles and miles and miles away to Atlanta. So you have to step this up to 120,000 volts to have enough push to get it from the power plant to the city. Then once it's in the city, it doesn't need quite that much voltage anymore. And so it steps down to a lower voltage to go from one town to a town to town, and then eventually going into your houses as a step down of 120. So the reason why this is so high is because you have to have a large enough push to get that energy from a power plant to a city that are miles and miles apart.